Good day, everyone. Today's topic, we will be discussing the network layer. To better understand this lesson, let us discuss first some terms that we will be using in this topic. Number one, packet is a small amount of data sent over a network, such as a LAN or the internet. Number two, Internet Protocol or IP address. It is a numerical label which assigned to each device connected to a computer network, which uses the IP for communication. Number three, Transmission Control Protocol or TCP allows developing a virtual connection between a destination and a source. Number four, Quality of Service or QoS is the process of managing network resources to reduce packet loss as well as lower network jitter and latency. Number five, router is a network device that forwards the packet based on the information available in the packet header and forwarding table. Number six, static routing is a technique in which the administrator manually adds the routes in a routing table. Number seven, default routing is a technique in which a router is configured to send all the packets to the same hop device, and it doesn't matter whether it belongs to a particular network or not. Number 8, dynamic routing is a technique in which router adds a new route in the routing table for each packet in response to the changes in the condition or topology of the network. Number 9, subnet mask tells which part of the IP address is the network and host part. Let's now go to network layer. Now, the network layer is a portion of online communications that allows for the connection and transfer of data packets between different devices or networks. The network layer is the third level or layer 3 of the Open Systems Interconnection Model or the OSI model. Data is transferred to the receiving device in the form of packets via logical network paths in an ordered format controlled by the network layer. Similar to a real life package, each packet includes a source and destination as well as the content or data being transferred. When the packets reach their destination, they are reassembled into a single file or other contiguous block of data. We now go to the four process in order to provide end-to-end transport. First, we have the addressing of end device. Now, addressing an end device refers to the IP addresses, which must be unique for identification process. Second, we have encapsulation. Encapsulation is the protocol data units from the transport layer are encapsulated by adding IP header information, including source and destination IP addresses. Next, we have routing. The network layer provides services to direct packets to other networks. Next, we have de-encapsulation. The destination host decapsulates the packet to see if it matches its own. As defined earlier, Internet Protocol is a numerical label which assigned to each device connected to a computer network which uses the IP for communication. IP address specifies the technical format of the addressing and packets scheme. Most networks combine IP with a TCP or the Transmission Control Protocol as defined earlier. The first network layer protocol is the IPv4 or the Internet Protocol version 4. The IPv4 was first version of, or is the first version of the Internet Protocol. It was developed for production in the ARPANET in 1983. Today, it is the most widely used IP version. It is used to identify devices on a network using an addressing system. Till date, it is considered as the primary internet protocol and carries 94% of the internet traffic. We are referring to the IPv4. The second protocol is the IPv6. Now, the IPv6 is the most recent version of the Internet Protocol. Internet Engineer Task Force initiated it in early 1994. This new IP address version is being developed to fulfill the need for more internet addresses because there are so many computers now connected on the internet, so we need to develop a new IP protocol version, okay, to accommodate the computers being connected on a network. Now, this IP address version is being deployed to fulfill the needs of more for more internet addresses, as mentioned earlier. It was aimed to resolve issues which are associated with the IPv4. Now, the next is the key differences in the IPv4 and the IPv6. First, we have, let me zoom in. Okay, IPv4 is 32-bit IP address, which means IPv6 is a 128 bit IP address. Another, IPv4 is a numeric addressing method, whereas IPv6 is an alphanumeric addressing method. Next, we have IPv4 binary bits are separated by a dot, whereas IPv6 bits are separated by a colon. Like for example, 198.198.256.256. Okay, so in IPv4 we use dot, semicolon or colon, sorry, for the IPv6. Okay, next, IPv4 offers 12 header fields, okay, whereas IPv6 offers a 8 header fields. Next, IPv4 supports broadcast, whereas IPv6 doesn't support broadcast. Next, IPv4 has checksum field while IPv6 doesn't have checksum fields. And lastly, okay, IPv4 supports VLSM or virtual length submask, whereas IPv6 doesn't support VLSM. Now, additional key difference of the IPv4 and IPv6 is IPv4 uses ARP or Address Resolution Protocol. Okay, this is used to map the MAC address, whereas IPv6 uses NDP or the Neighbor Discovery Protocol to map the MAC addresses. Next, we have the key features, okay, of the IPv4. Zoom in. Okay, so we have 5 features of the IPv4. Here are the following features. First, we have connection protocol, connectionless protocol. Second, we have allow creating a simple virtual communication layer over diversified devices. Next is it requires less memory and ease of remembering addresses. Next, we have already supported protocol by millions of devices. And lastly, okay, offers video libraries and conferences. This is one of the reasons why IPv4 is still considered as the most used type of protocol in the network layer. The next feature is the the features of IPv6. We have four features. Okay, zoom in. Okay, first is hierarchical addressing and routing infrastructure. Second feature, stateful and stateless configuration. Number three, support of quality of service. Okay, and lastly, we have an ideal protocol for neighboring node interaction. So what is the difference between an IPv4 and an IPv6? Okay, here are the following differences. IPv4 and IPv6 are both IP addresses that are binary numbers, which is a series of numbers of ones and zeros. Okay, IPv4 is 32-bit binary number, while IPv6 is 128-bit binary number addresses. IPv4 addresses are separated by periods, while IPv6 address are separated by colons, as mentioned earlier. Both are used to identify machines connected to a network. In principle, they are the same, but they are different on how they work. We now go to routing. Routing is a process of selecting path along which the data can be transferred from source to destination. Routing is performed by a special device known as a router. The routing algorithms are used for routing the packets. Now, the routing algorithm is nothing but a software responsible for deciding the optimal path through which packet can be transmitted. Now, the routing protocols use the metric to define or to determine the best path for the packet delivery. The metric is the standard measurement such as hop count, bandwidth, delay, current load on the path, etc., used by the routing algorithm to determine the optimal path to the destination. Now, routing algorithm initializes and maintains the routing table for the process of path determination. Now, there are three types of routing: static routing, default routing, and dynamic routing as defined in the terms earlier. Lastly, we go to the default gateway. This will be the last topic for this discussion. Now, a default gateway, when a host wants to reach a destination that is outside of its own network, it has to use a default gateway. In the given illustration below, we have two hosts connected to a switch. We only have network 192.168.1.0, okay, with subnet mask of 255.255.255.0. When one host wants to send something to another host, then it will check if the destination is inside or outside its own network. When the destination is in the same network, then it will use ARP to find the MAC address of the destination, and it can send the IP packet. How does the host check if the destination is in the same network? Well, this is done by checking the submask. And that concludes this topic. Thank you for watching and listening.